Welcome. Uh, this session we will see how to plot ILD for a truss member. So here I am choosing a top chord member to start with. So this session we will try plot ILD for member U to U3. Okay. So I have taken a section here. Let us say section XX. Now you cut the truss at this section where the member U to U3 is present, whatever you have chosen. So after you cut the truss, you see the right part of the truss and the left part of the truss. Okay. So once you taken a section, now by definition from ILD, what it says, when one unit load travels across the truss. So let me draw one unit load here. So one unit load as it travels across the truss, how the member force in U to U3 changes. The plot that shows is called ILD for this member force. Okay. So now you assume a one unit load is traveling from U1 to U7. Okay. So if the ILD shall be plotted in two parts, when the load is to the left of the section and when the load is to the right of the section. Okay, let us say when the load is to the left of the section means anywhere on U1 or U2. As you know, the truss loads shall be only on the joints. So when the load is occupying any position between U1, U2 or U2, U3, now you will be transferring the load to the joints. Okay, so that is learnt in trusses. Okay, truss analysis. Right. So for instance, now you are taking the load is onto the left of the section. Okay. So load to the left of section. Okay. Now when the load is to the left of the section, so if you just recall method of sections, okay, so you will consider a section across the truss. And when the load is to the left, so you have to take any one part for analysis, either left part or right part. So as the load is to the left, now I choose the right part. Okay, so choose right part. Okay, so to start with, we have taken one unit load is onto the left of the section. So when you say left of the section, the right part will have less number of loads. In fact, there is only one load, that is reaction at this support, no other load at all. Okay, just one unit load is traveling on the truss. So I have chosen the right part. So you have only one force there, that is say RB, right? It's just RB. Okay, let it be RA and this is RB. So only one force here. Now at the cut surface, you shall draw the forces in the members, So you need to see what force is acting in that member. So these are the forces which are acting, which have developed in the member. So we want only this force. This is named as F U2 U3. The other forces you don't want to find. So when you recall method of sections, okay, so you choose equilibrium equation to get only this force, okay, leaving the other two unknowns. So I go with the moment equation. So I take moments about L2 0 so that the other two unknown forces will not come into the equilibrium equation. Okay. So now I am writing equilibrium equation, which is sigma m L2 is equal to 0. So you choose one direction as positive, either clockwise or anti-clockwise positive. So let me say clockwise positive. So you have four forces total onto this the part of the truss that is being chosen. Okay, you have four forces. So out of four, you don't want these two forces. You want only this top chord member force, and you have a reaction. So this reaction can be found from the given loads just by the equilibrium of the total truss. Okay. Right. Now writing moments about this point will eliminate these two in the equation. So just writing that equation. So these two forces multiplied by zero distance and RB multiplied by this distance. Let us say each span is A. So you have four spans here. It will be 4A. Okay. So this is anti-clockwise. So let us keep negative sign as you have taken clockwise positive. The same thing here, as the height of the truss is taken as h, let us say. So this force multiplied by the perpendicular distance is h. So write F U2 U3 into h. That is also anti-clockwise. So let us say minus is equal to 0. So we want this force. So sending this to the right hand side, F U2 U3 is equal to, I mention this as the minus moment about L2 divided by h. This is F into h, right, to the right hand side. So now you see when the load is to the left of the section, the force in this member, the force in this U2, U3 is proportional to the moment at this point. Okay, is proportional to moment at this point. Otherwise, moment divided by, if you want exact value, moment divided by height of the truss. Okay, so this force in the member is following the bending moment at this joint L2. Okay, right. Now go for the other part of the truss. Now let the load cross this section and travel to the right part. Okay, load is now on the right part. So I choose the left part. Okay, so now the load is on this part, right? Okay, load is traveling like this on this part. So I choose the left part because right part now has got two loads, whereas left part has got only one reaction, let us say RA. Okay, so now load is on right part. So I choose left part for the analysis. So now the load is onto the right part. So I am choosing this part. So the forces at this cut section, I always prefer to give the outward direction because of the uniformity. As you see, the forces are assumed as tension. You know the top chord member is in compression, that's why you got negative sign, because I assumed tension here. So you got negative sign, which means this is compressive force. Okay, right. I choose left part. Again, I don't want these two forces to find, I want only this force to find, F U2 U3. So what I do, I'll choose again the same moment center. where these two are meeting, that is L2. Okay, so now write sum of moments about L2 is equal to 0 again. Okay, because I want only this force, I don't want these two forces. So same, you may choose clockwise positive or anti-clockwise positive. Okay, so taking moments about this point will make these two forces moments 0, and Ra multiplied by the distance is 2a, this is a and a, so Ra multiplied by 2a, you are taking moments about this point. Okay, right? So this is clockwise, so I choose clockwise positive, so plus value, and force u2 u3 multiplied by perpendicular distance between moment center and this force is h, and there is positive plus is equal to 0. Okay, so this is the equation that you got from the equilibrium equation. Now I want force F u2 u3, which is equal to, if I say this is taken to the right hand side, minus, it will be minus Ra into 2a is again, I am representing that as moment about L2 only, divided by h. Again I got negative sign because this force I have assumed it as the tension here, it is actually a compressive force. Okay, so again you see the force, even though the unit load is onto the right part, the force in this member is following moment about L2 only. Okay, so this is finally concluded as the force in U2 U3 is proportional to moment about L2. If you want a value, moment divided by h for whatever may be the position, whether you take it the load onto the left part or you take load onto the right part. So for both the cases, finally it has come to bending moment about this point. This force in this member is following bending moment about this point. See, for one unit load moving onto this span from U1 to U7, you can draw ILD for bending moment at a section, that is at a point now, L2. Okay, so that if you do, okay, so let me just copy down the diagram there. We will plot now the ILD. Right. So choosing a color for this plot. So let me just make it up. Yeah, now we need to plot ILD for this member U2 U3. So it is following ILD for bending moment at this point. So you can easily point out this point, like it is the other two members meeting in that particular panel. So if you take this panel, in that panel where the other two members are meeting is L2. So at that point you need to plot ILD for bending moment. Okay, so there is 0 here, so just join these 2 points. So you know how to plot ILD for bending moment, just follow the previous lectures that I have posted for how to draw ILD for bending moment. Now you see, so if this is x, this is L minus x. So the ordinate here for bending moment ILD is x, L minus x divided by L. Now this ILD for bending moment will become ILD for force in U2, U3 when you divide this by H. Moment divided by H, that you got relation between the force in the member to the bending moment at this point. Okay, so now this is compression. So this is ILD for the force in this member U2, U3. Okay, so this is how you plot ILD for now the top chord members. Okay, similarly for any other member, like if you want for U3, U4, okay, take the opposite joint here. Okay, plot ILD for bending moment at this point, divide it by H. Okay, likewise you can plot. Similarly for this member, so the other two members in that panel are joining here, L1. So plot ILD for bending moment at this point and divide it by H will give you the ILD for the force in U1, U2. And as you see, this symmetry. So these three diagrams will just replicate U4, U5, U5, U6 and U6, U7. So likewise, for any top chord member, you can easily plot the ILD for the force in that member, right? So this is the procedure for how you plot ILD for a truss member. Now when you are given some loads on this truss, for moving loads, you know how to use this ILD. Just follow the lecture from my previous videos, how to use ILD. Okay, right? So that's how it is. Thank you.